In this week's episode of the AWS Developer Podcast, we're talking about a new API for Amazon Bedrock, the Converse API. Stay tuned. Hello, fellow developers. I'm Seb. I'm the new host for the AWS Developer Podcast. And today, in this episode, this Friday, we're going to talk about generative AI for once with my guest, Denise Straub. You're part of the Developer Experience team. And you wrote recently a blog post and a couple of code samples for this new API, Amazon Bedrock Converse API. But before getting into that API, maybe we can briefly recap what is Amazon Bedrock, Denise?
Actually, it's not one thing. It's. I think it is a family of services that does a lot of things. It provides, on one side, it provides basically a bedrock, like in a river, where all the new foundation models that are being built these days are available, and you can just use them through an API now through the Converse API. But there are other ways as well. But in addition to just using the models, you can also fine-tune some of them. You can use agents. You can evaluate models. There's an evaluation API that helps you basically match,
like compare them,
compare models against each other.
Mm-hmm.
There's guardrails. You can define guardrails. You can use specific guardrails that help you make it like more strict in terms of what the model or what is allowed for the model to do. So there are many different things, and this is still a very evolving space right now. Everybody, I think, there's so many things happening right now. So Bedrock, basically, it's a family of services around generative AI foundation models for image generation, for text generation, for multimodal interactions.
And it's brand new. It's just a few months ago that we released Bedrock,
yeah,
correct?
We released it, I think, in September last year. So, yeah.
Last year, 2023. So it's only a few months old. So one of the things I like with Bedrock is that there is one API, I, as a developer, that I can call to invoke many different models. It's invoke model, and I can call Llama, Mistral, Claude, and others. But developer told us there are a couple of challenges when doing so. So what is the challenge we are trying to solve with this new Converse API?
Because as I said, everything's changing a lot, and it is really like a river flowing pretty fast right now. And when we started with Bedrock, every model provider was experimenting with their own very specific API because there was no standard. Everybody was experimenting. So every model used to have a very distinguished proprietary API. And what Bedrock did is to allow using all of these models was just take that API and give it to the developer through the Bedrock API, through the invoke model API. But that meant you had to deal with raw JSON. That meant you had to deal with very different schemas and object structures in the request, in the response. And that's pretty easy when you use Python or JavaScript, but it's getting really hard when you have typed languages like C# or Java or anything, where it gets really hard to deal with raw JSON strings.
Yeah, because then you have to write an object model, a DT or whatever we call it, a structure, a class, for every specific model. So if I'm talking with Claude or Llama, I need the payload of the Bedrock API is different. It's specific to the model. That's what you're saying.
Right. And you, as you said, you have to effectively either use some JSON libraries that are available, but they're still hard to use, or you create your own abstraction based on the model-specific API. But in that case, it's a lot of work on you. That's a lot of different heavy lifting that you have to do instead of just using the API with different models, which effectively is the promise of Bedrock. You can use different models. You can switch. You can evaluate models against each other and then switch between them, even use multiple models for different use cases within the same application.
But developers have to write specific code or specific payloads for different models, which, as you said, for Python and JavaScript, it's quite easy. You just type your things in the code. But for Java, C#, Swift, Rust, and all these strongly typed language, it's a lot of code. So how do we solve that problem? What is this new Converse API? By the way, I love the name of the Converse API. For once, I have an API named after my shoes, but it has nothing to do with shoes.
Oh, we were debating the name a lot because the idea arose really to have an abstraction on top of like a chat, specifically with text-based models, with text generation models. But while designing the API, we realized there's so many more things that we can do. But something that evolved at the same time across the entire industry was some kind of a standard, a quasi-standard with messages, where you have an array or a list of messages, and each message has a role, like user or assistant, which are the two roles in a conversation. And the Converse API has been built to solve two problems. The first problem really was the fact that every model has its own very specific proprietary API, and we wanted to provide a unified API across all of these models. And at the same time, there was an evolving standard that we wanted to integrate into Bedrock as well, of course. So the messages, the type, the way you have conversations with a generative AI foundation model has been standardized. And OpenAI and Anthropic did a lot of work in that regard. And we are at a point, we hope, where this is somewhat stable. And the Converse API takes exactly this structure and puts it on top of every individual model. So you don't have to care about the specific API of each individual model. You can just use one API, and it's strongly typed. So you have types available for Java, for C#, for Kotlin, for Go, where you can just use the type, integrate it into your language. And one of the huge benefits is you even have things like IntelliSense, where your IDE tells you how to use the model instead of having to figure it out by looking into the documentation, which is sometimes really hard depending on the model provider. And even within model families, Llama 2 had different standards than Llama 3. Cohere Command has different standards than Command R and R+. And
so it's a Bedrock specific abstraction above the current models that are available on Bedrock. And when you say there are types, it's part of the official AWS SDK.
Yes.
That's how I understand it. So if I use the Java SDK, I have a Java class that will represent that type. I don't have to type it myself. With the extra benefit, I didn't think about that, but you're right. Right in my IDE, I can have code completion provided by the type system of the language. So let's look at that API. First, is it still Invoke model, or is it a different top-level Bedrock API?
It sits on top of Invoke model. So you will see that if when you set up your permissions, your IAM permissions to use the API, you still have to use Invoke model and Invoke model with response stream to be able to use Converse and Converse stream, which is the equivalent, but it's an abstraction on top. It's basically a layer that we provide on top of Invoke model. You can still use Invoke model, and for many modalities like image generation, the Converse API doesn't really make sense, at least for now. Maybe it's going to evolve. Maybe there's going to be another one. However, right now it doesn't make sense to use it. So you will still be using the Invoke model API, and
yeah, it might make sense for some use case. One thing I don't understand, is it a new Bedrock API? I mean, at the REST level at Bedrock, or just a construct inside the SDK? Because you said in IAM we just need to authorize Invoke model, so the low-level Bedrock API. Is there a new API to allow in IAM?
It is an API. You can call it directly through HTTP. You can make a call directly to Converse or Converse stream instead of Invoke model and Invoke model with response stream. However, underneath, in the plumbing, it sits on top of Invoke model. And IAM doesn't need to care about different abstractions. IAM just cares about the fact whether you should be allowed to use the model or not.
So how should I use that new API? How can I feed a system prompt, for example? Or maybe what is a system prompt? And then how can I feed a system prompt into that API?
Okay, a system prompt. A system prompt is it's basically a prompt that you use to prime the API, to give the API some context, some guidelines, some restrictions maybe, telling it how it's supposed to interact with the user. Very often, especially when you build applications, if you don't sit in front of a chat, like ChatGPT, for instance, that is an application. That is not the model. It is an application sitting on top of GPT. And the developers building ChatGPT have to be able to tell GPT
How to
behave in this specific environment, in this chat, as being part of a chat application. So if you build an application that uses generative AI, there is a context. There may be a business context. For instance, it could be a chatbot that has the sole responsibility of telling you the weather. So to be able to ask for the weather in natural language. And this model shouldn't be discussing everyday things. It should only provide you with weather, and it should, in addition, maybe use specific tools to retrieve the weather, because at least right now AIs are not available to look out the window and see the weather. They have to use certain other applications, tools, APIs, and this is what you tell the model effectively in the beginning of a conversation, invisible to the actual user of the application, where you tell the model what it is, what it's supposed to do, what it's not to do.
So, for example, if I'm writing a unit test in Swift, I'm writing, you're a senior Swift developer, please write a unit test for that function. And you're a senior Swift developer, it tells the model the context, the tone of the answer. That's the system prompt. That's a good example. Maybe you have other examples.
Yes, that's the system prompt. Another example would be if you look at Amazon Q Developer, for instance, as a coding companion inside of the IDE that helps you. One of the things the model needs to know is the purpose, and the purpose is very specific when it's supposed to help you with development. But in addition to the purpose, it needs to be aware of the fact that there is a code base for it that it can access. So it doesn't just come up with something. It knows there's data it can access that you make available. So it understands your code base. And at the same time, that there is a body of knowledge, maybe in a database somewhere, or in a repository somewhere that it also can access if it doesn't know the answer, if it needs to look it up. And all this information, the model doesn't know that. It has to be told. And if I work in my IDE, I can't always tell the model where it should look.
To repeat,
hey, this is my code, and it just knows. And that's what the system prompt does. It's transparent to the developer or to the user of the application, no matter what the application is.
And the syntax to define that system prompt is specific to each model. I remember some of them have in between brackets, some have a separate parameter in the JSON. So now it's unified. We have like a property system prompt that will be transformed to whatever the model expects underneath.
Exactly. There's a top level. A top level property on the API, which is system, and that again contains an array of objects. And right now, this can just be a text object, but in future cases, this may include, for instance, guardrails, telling the model specifically which guardrails to use to make sure that it stays within the bounds of the specific application.
And we apply the same idea to inference parameter, the top key, top pay, temperature that have slightly different spelling from one model to the other. So now there is a standard block for these inference parameter, the hyperparameters, as you call
it's
them.
the inference configuration in the new API, and the inference configuration contains temperature, top P, max number of tokens, and a stop words. Stop tokens, basically, to tell the API if there's specific terms that signals that it needs to return the response instead of continuing to talk like I do.
And if I want to pass a specific parameter to my model, which is not supported by the Converse API or not integrated, there is like a escape hatch or an escape door where I can feed raw JSON.
Yes, you can't feed raw JSON. However, you can access all the native fields, the request fields and response fields through the API, because as I said, the inference configuration only provides temperature, top P, max tokens, and the stop token.
And the stop, these are the most common for most of the
Not every model
models,
has top K.
That.
Not even every language model has top K. But if you want to use it, you can still send an additional request parameter. So there's another property in the API, another top level property that allows you to specifically say which additional parameters you want to use. And on the other side, you can also tell it which additional response fields you want to have inside of the response. So the response will contain the default response. And in addition to that, based on the path you give it, the objects inside the JSON response of the model that you access through this JSON path effectively.
Through the JSON path, yes. You mentioned something about conversation. That's only a subset of the usage of generative AI is the chatbot, but it's the most visible right now. I hope it will change in the future, but that's a different conversation. What is special about conversation? One of the things I was surprised with when I started developing against Gen AI like 1 year ago is that the models have no state. So when you do a conversation, you have to send at every turn of the conversation the entire history of the conversation so that it can keep track of the context. What is the Converse API? How the Converse API can help me to write a chatbot and to manage these conversation terms?
The Converse API uses something like a conversation history. It's called messages, and it's just a list of individual messages, conversational turns. It always starts with a user message, in addition to a system prompt, which is separate from that in a separate block. It always starts with a user message, and the next message is an API response, an AI response, and then it's called assistant. The roles are user and assistant. It goes back and forth. So you can use it for both, either for a one shot, if you just needed to do something and get back to you, then you just send one message inside of this block, or when you start a conversation. However, if you want the model to retain the history, you can just take the response, which contains the entire history that the model knows about, and you can append. No, I'm sorry. Let me rephrase that. The model returns its own message as a singular message block, and then you can just append that block to your own list of messages that you have. So your application maintains the state.
I need to maintain that.
Application maintains the state inside of a list, inside of an array of messages. And you can just append the message from the model. And then the next message from the user, you create that one, and then you append it again, and then you send the entire history back to the model. One of the challenges with that is that the history can become quite long.
Can grow,
quite lengthy,
and we have to know the context window, so the maximum size of a question for each model, or the API takes.
No, we have to be aware of the context window, and what is much more important is specifically today, when the context windows are so large, it can become quite expensive if you use all of that. If you send like 10 books with every invocation. It consumes a lot of compute power because it has to process all that information. So you still need to have to employ strategies to reduce the size. And some strategies are just dropping the first messages at some point, just cutting it off.
The oldest one,
which is something that you may have experienced when talking to these chat bots, is that at some point they start forgetting things. They start forgetting. And this is the reason it's just being cut off, or it's being condensed. And one of the things you can do inside of an application is, again, to ask internally the AI to
To summarize the conversation.
to summarize the conversation so that you can use that one inside of the conversation instead
That's
of the entire.
smart. I love it. Yeah.
And that can be very effective.
And when you say effective, you mentioned the compute power and the time it takes to process that. I would add the price as well, because Bedrock is on demand for most usage, or you can have provision throughput as well, but on demand, and the billing is per token, so roughly per words that are sent as input and words that are received as output.
Yes, so the ratio is about, in English, it's about 1 to 3. I think that every word is on average 2 to 3 tokens. It's different in German or other languages that have these monstrosities of. Yes, so the unit of work and the unit that's being paid for is individual tokens. It's basically mathematical representations of words or an image or whatever you send to the model. And the more you send, the more the model has to process and work, the more GPU power it uses, it needs, the more memory it needs. And this is what
the more will take on your credit card.
This is what makes it a little bit more pricey.
So, something that excites me a lot about this new Converse API is the tools capabilities. Yeah. And there is a 4-part blog post from one of our colleague named Jason Steele. I was forgetting his name. Sorry, Jason. That explained that in great details. Can you explain me what is a tool and why developers should be excited like me about tools?
As I said before, at least now, the AI can't look out the window and tell you what weather it is. It doesn't know the time. Oh. It's stateless. Whenever you send a request, it's being pulled from its cold store, basically. It's being brought to life. It takes the input, it generates the output, and then it goes to sleep again. It doesn't know about the context. It doesn't know about time. It has virtually no self-awareness. It is stateless. And if you want to use things like time or the weather, or access a database, access specific information, access an external API, anything, whatever you want to do, you can plug it into the AI as a tool. So I just wrote a demo. It's not alive yet, but I'm going to give you the link once it is. I wrote a demo that is just a chatbot that tells you the weather. It's very simple, but its purpose is to demonstrate how it works. And the way it works is, in the system prompt, you tell the AI that it is a chatbot that provides weather and nothing else. And that there is a tool available that it can use to get the weather. And this tool has an open API-based JSON schema which describes exactly what it needs, the parameters and the output values, the output schema, and exactly what it does, so that the AI understands, okay, this tool gives me the weather and it needs latitude and longitude in a specific format, and it will return an object, a JSON object that contains all the information that I, as the AI, then can process. So what I do in the application is I give it that system prompt, and within the call, I let it know about the schema of the tool. And then I send it the conversation. And the beginning of the conversation is just, what's the weather like in New York? Or does it rain again in London? And
so what is the initial response that you receive?
The initial response is, because the AI determines, well, I know.
I cannot answer that, but I know that I have a tool.
Know the latitude and longitude of the location, but I don't know the weather. But I do have the tools, so it responds with a message block that doesn't contain a response for the human, for the user. It contains a response in the form of a tool use request. And this tool use request has exactly the structure and the values that the tool requires. So what it
So it's matching the parameter that he has. He knows, like latitude and longitude, to the actual parameter of the function that you described to the model.
Right. So it returns a tool use response. It may also additionally return a text response telling me, wait, I have to look it up. At the same time, as a developer, you receive a tool use request, and then you can have your own application orchestrate that, send it to the tool, depending on what specific tool is being requested, because the tool use request contains the name of the tool that you have defined, and it contains the request body to send to the tool that is defined in
the mapping of the parameter.
Exactly. And your application can take that, send it to the tool, wait for the tool to respond, whatever it is, wait for the...
And the tool can be a local function, can be a REST API, can be a system call.
Yeah, it can be the system clock.
Can be anything.
It can be the system clock. But it needs to be wrapped in JSON. So you need to have... You somehow need to wrap the response... Well, no, actually it doesn't. You can map it yourself. Well, it needs to be mapped, but you have to map it yourself if the tool or API doesn't. And it returns the response, and the response can be unstructured. It can just be a blob wrapped into a JSON object, into a top level field in a JSON object. It can be a blob or a clob, a character large object, and the API. You send that back to the API. You append that to the conversation. Send it back to the API. The API comes to life again, looks at the conversation, sees, oh, okay, I was asked for the weather in New York, and I responded with a tool use request with this and this ID, and I got a tool use response with this and this, with the same ID. So most likely, the payload of that response is the answer to my tool use request, and it can look at it, and irrespective of the shape of it, it can try to understand the content and derive the temperature and the wind and turn it back into natural language that it sends back to the application, and the application can display it to the user.
So let me try to refresh just to be sure I understand you correctly. A tool is something first that I need to code as a developer. It's like an orchestration of using the large language model for two things. The first thing is to categorize. That's something they can do quite well, saying, hey, I have this set of tools. These are function or REST API or any type of API, and I give a description to the large language model of the tools that I have. And when the customer asks a question, when my client asks a question, I pass to the model the question, and I basically say, hey, is there any tools that can help you, that can help me or help you to answer the question? And usually the large language model will do a categorization saying, yes, that tool, and these are the arguments in and out, the parameters in and out. And then in a second step, I, as a developer, call the tool that the large language model told me to call, and I pass the result of the tool to the large language model again, so it's a second call to the large language model, this time to shape an answer, because that's what large language model can do, create text. So if I give the question, the answer provided by the tool, it will generate a human answer. It's very similar to LangChain agent, for example. Are we in the same category here?
Chaining, you can chain. The agent is effectively on your side. You built the agent. You have your API. You have
that's a big
you have the tools, and your application has a router or anything like that takes the tool use request from the model and routes it to the respective tool and returns the response. So as you said, it is a two-turn process. The first turn is to send the original message along with the tool specification to the model. Then the model realizes, all right, I need to use one of the available tools, sends back the tool use request. Your application forwards this tool use request to the tool and then sends the response from the tool back to the AI. And the AI then determines whether it has everything it needs or maybe needs another tool use request. If you look at the weather example,
it can be as complex as we want. It might be multiple steps and calling multiple API
imagine
generating the final answer.
Right. Imagine the weather app doesn't know latitude and longitude or isn't sure about it. And that's the thing. In the system prompt, I can tell it only provided if you're really sure. Don't make anything up. And if you're not sure, here is another tool that has geolocation information, which will give you the latitude and longitude for any given location. So the model may realize, all right, I got the name of a city. I'm not sure about the lat and long. So I'm going to send a tool use request. Once I get the tool use response for that, then I can send the tool use request for the weather API.
Mm-hmm.
And once I get that response, then I return the final response. So you have two parts to the orchestration. One part is your application, which is a router. It provides the tool definitions and routes the requests. And the second part is the API, because the API then decides which tools it needs and in which sequence, and whether it needs another tool before being able to provide the final answer.
I'm super excited with that because it means a large language model can interact with real-time data, like the weather is a perfect example. The other example I'm using most of the time is stock quotes, you know, the price of the Amazon stock, for example. But it can also act on the reality. I mean, it can book a table at a restaurant or book a flight or search for availabilities in an hotel, for example, or the nearby electric scooter in my city. So it really opens up tons of new use cases for large language models. What are the things fellow developers, the listeners of this podcast, needs to pay attention of when dealing with Bedrock in general?
One of the things that are really challenging right now, and this is not going to change for some time, is that we all, not just we at AWS, everybody is still on day one when it comes to this. Everything is so new. There is a standard evolving. The Converse API, for instance, builds on top of this evolving standard. However, there are so many new things happening, so many things that haven't been discovered or invented yet. We still are in the place where we just try to use our traditional way of thinking and apply it to AI. Right now, we are just taking every use case and mapping it onto AI, even though it has been solved already. We don't need to use the AI to do many of the things that we're trying to do with AI right now. And we shouldn't, actually. It's okay to experiment, but for production use cases, if the problem has been solved already, if it can be solved deterministically with an algorithm, with a traditional deterministic piece of software, use that. Don't use the AI, because the AI, it's much less deterministic, and it's much more expensive, because it's much more involved to train the model in the first place, and then to use the model. It's more expensive in terms of resources and also in terms of money. So please try not to just do everything with AI now. And what I'm trying to say in addition to that is really that we don't really know how AI, and specifically generative AI, can really be leveraged. We're still waiting for that breakthrough. It's like with mobile devices. I don't know if you remember the Windows phones where you had this small pen where you tried to hit that start button, because the traditional desktop UI was just transferred onto that small device and it didn't work. And then Apple,
we have to invent something
new. Apple embraced the new medium. And Palm OS did in some way or form as well before that. However, at some point, the new medium was embraced, and all of a sudden, it was transformed, and it transformed the way we communicate, the way we work, and everything. And we weren't able to anticipate that. I think it's the same with AI, especially with generative AI. We're still in the process of trying to build Windows Mobile and use the new medium for traditional and already solved problems, instead of embracing it to solve new problems.
new problems. So carefully select your use case. There is an impact on the environment as well. Generative AI costs a lot of money, not only on your credit card, but also in terms of energy consumption. So think about that. In the last few months, Denise, you've written a lot of code sample for developers that landed in the official Bedrock documentation. Why?
Because I don't. Because, can I say it? I don't like Python. No, the thing is, I don't have a math degree. I don't have a science degree. I grew up writing PHP in the late 90s. I wrote Java, C#, even Perl, some different languages. And AI, for me, it was a closed book. Until just recently, it was a closed book. I didn't understand how it works because I don't understand the math behind it, the science behind it. So I didn't know how to use it. And I think most developers didn't. And people working with AI almost exclusively used either Python or MATLAB or R. All three languages. Well, I know Python. I understand Python. But I prefer working in other languages. And now with generative AI and tools like Bedrock, you have access to it with all kinds of languages, and you can use it just through the API. You can use the AI just through the API using the SDK for your specific language. But when I was looking at examples of how it works, the only thing I found was Python. When I look at what's being produced in the documentation, in many of the examples that are being created inside of AWS as well, or with customers, most of it is in Python. First, because Python is fairly easy to write and read, and it's also still the lingua franca of the data and AI
science.
engineer, not AI, ML engineering community. And I'm becoming something more like an AI engineer, where I'm a software engineer who uses AI. I don't need to understand AI, and I want to use my own tools. I want to use Java. I want to use C#. I want to learn Go or Rust and still be able to use it. And this is why I figured we need examples, getting started examples, specifically showing you how the API works, how you can use it with your own idioms inside of your own language and environment, and don't have to use Python.
As good as Python can be, but yes, it's about diversity and inclusion in this case. We have all these SDKs that are available. You mentioned them. We have PHP, we have Swift, we have Rust, and so you're embark on a journey to include all these developers inside the generative AI story.
And I must admit that the documentation in the other languages has some room for improvement. It really does, because traditionally we have focused a lot on Python because many AWS services are not used on a daily basis by developers. They're used when you set up ops. They are they're used in the console sometimes, but most of the time using infrastructure as code. They're being set up and maintained, but you don't have to work with them every day. But APIs like SQS, for instance, or SNS, or Bedrock, these are inherently AI-driven products that developers use, that developers interact with to embed them into their own applications. And so it's very important for us to recognize and acknowledge the fact that these people, including myself, want good documentation and good examples, at least to get them started in their own language. So they can really experiment with it without first having to install Python and set up a virtual environment and everything that entails. Especially if you use Windows, which is sometimes a mess if you want to use Python.
Yeah, that's correct. And the Java and .NET developer thanks you for that. All the links of the things we talk about are in the notes of this podcast. So in your app, you scroll down a bit, you will find the links to Denis' blog post, to Jason's blog post about the tools, to the documentation, the code sample in the documentation as well. So don't hesitate to click and to provide feedback. You have also the social media contact from Denis. Denis Straub, you're part of the Developer Experience team I'm based in Germany. Thank you for explaining the new Converse API for Amazon Bedrock in this episode. Thank you, for having listened to this episode until the end. Next week, we're going to talk about the new command line tools that allows to deploy a web application behind CloudFront, and we'll explain why and how you can take advantage of this tool, but that's for next Friday. See you next week. Enjoy the weekend, and whatever you code by then, make it count.